Okay. Um, Hello viewers. You are welcome to this YouTube channel, and this is what illuminates what tutorials. And I'm Stanley by name. So today I took upon myself to take the topic probability, in which most of us found it difficult to understand, or let me just say difficult to understand. But today, with the help of the of God's wisdom, I'll be able to explain it bit by bit and to make it understandable enough so that anytime you come across a question that involves probability, you'll be able to solve it or to deal with it to look like a piece of cake for you. Now, without wasting much of our time, now let's move on to the topic of what today, which is what probability. Now we all know that probability is a thing of what chances. Now, a proper definition, we can say probability is what how likely what an event is to what occur. Is what how likely what an event is to what is to occur. Now, there are some key things, key points, or key things to note in what probability, which are let's move on. Now we have one. Now, if you solve a probability question or you solve a question and is what one, that shows that what is certain. Now, one is what 100% sure that is going to happen. Now, one shows what possibility. Now, one shows what possibility. Then then we have what zero. Now, zero shows what impossibility or impossible that the event is not going to what is not going to what happen. That's for zero. Now, zero shows that is not certain, is not going to happen. Impossibility. Why one is what shows that what is possible is going to happen. Now, why we now move on to what probability? Probability is not a whole. Why? Because it's a thing of chance. If something is one, that means it's not what a chance kind of thing again. That means it's what 100% certain that it will happen. Now, one is not a probability. Why zero is not what now one is not there. Now, why probability is what is fraction, is not a whole. Now, if I said a fraction, that means it has what is not a whole, it's not up to one. That means it's a thing of chances. Now, if I say okay, something is what 1/2 sure that is going to happen, that's what 50% sure. That means it's what 50-50. Now, in probability, the numerator is what the favorable what outcome. So just take note of that one. The number of a favorable outcome. Then we now have this. This one is now a total number of what possible outcome. Total number of outcome possible outcome. Now, just know this. That's a fraction. So, anytime you are dealing with fraction, this is what the possibility that the thing is going to happen. Then this is the total number of all the possible ways that is going to happen. Now, let's now move on. So, with this being said, now in probability, there are some key things you ought to know, which is what just know that a coin is involved and what a die is also in what involved. A die, die is one. Then we also have maybe like card, like what they call it deck. Now in a coin, we have what two possible what outcome, which is what a head. It can either be what a head or what a tail. Now this is what the possible outcome is what two. Then y for die is what six-sided, and the possible outcome is also what six. Then we now have this, in a die, you have one side is has only one dot, the other side two, the other one three, four, five, and so on till six. That's the side of a die. Now, why for a deck has what 52 what seats. Now you can just do more research on this. A deck has what 52 seats. Now in that 52 seats, it has what 13 club, diamond, 13 diamond. Let me just shorten it. Then 30 spade and 13 hearts. So you can just do more. So everything add together give us 52. Now under the 13, we have 1-1, either a sub under it, that's ace, king, queen, all those kind of stuff. So you can just do research on it. Now, in this now, if a coin is what is being flipped, now you either have what a head. Now the head there that you have, or you either have what a tail. You can't have the two at once. Now, the if you flip it, you either have a head or a tail. Now, that the head or the tail that you have is the favorable outcome. Why the total number of possible outcome is what two, which is what the head and the tail joined together that give us two. Now, if you roll a die, you either have what one, two, three, four, or five, or six. Now, if you roll a die, you have three. The favorable outcome was three. Why the what possible outcome was what six. Now the same thing with deck. and so on and so forth. So let's now move on to the business of today. Now, why I wrote the question on the board is to reduce the duration of the video so that it will not look bunky, so that it will be easier or simpler to understand. Now, let's now move on. Now, under probability, there are sub under it. But I don't call it, I just summarize it, the major thing, everything you need to know. That's why I call it a summary of probability. Now, we have what the multiplication. This marker. Okay, we have what the multiplication of probability. Multiplication of what probability. Then we have what addition. Addition of probability. Let me just write addition or subtraction. Subtraction is included. The subtraction is just a minor. Why this addition is what the major. So in probability, you either have what multiplication, addition, with a little bit of what subtraction. Now under this multiplication, that's when we have the dependent or the mutual. Let me write it in the bracket. Mutual. Then we have the experimental. Let me just write it. Experimental. Experimental what probability. Now under the multiplication, we have the mutual and the independent. Independent what probability. Let me just bracket it. While the under the addition, we have the mutually exclusive, and the mutually not exclusive. So now under the experimental, that's where we have the flipping of the coin and the die and the die and so on with the deck. Now that's for the experimental. Now this experimental can lead to what the multiplication and what addition of what of probably of events. So the experimental can lead to it. But while the multiplication will lead towards the mutual and independent, addition will lead towards mutually exclusive and mutually what not exclusive. Now under the experimental, that we have the flipping of the coin. I've said that. Then why for the mutual and the independent? You know, in biology we did what parasitic relationship. We have the mutualistic one, symbiosis, all this kind of stuff. Then why for this mutual? And shows that the one, if the other event occur, the occurrence of the first event will affect the second one. Now in an instance now, okay, when we are solving question on it, I will explain it. Now the one event is dependent on the other one. Now we can also use dependent for this mutual. Now that means one event, that means it involves two events. That's why we have this mutual independent. So if it is what two events, that means one event will be dependent on the other one. Then why for this other one independent? Independent shows that is not what dependent on the other one at all. The first event is not what dependent on the second event, while the second event is not dependent on the first event. Why for this experimental? It's just that if you read that you either have one head or the head, all this kind of stuff. That's experimental. Experimental is just one. The one will now come to this addition and multiplication involve two events. Then why the dependent? I've explained that. Why the addition one? Now addition, when we now have the mutually exclusive and mutually not exclusive, then the mutually exclusive is simply that the event cannot occur at the same time. It cannot what occur at the same time. Then why this the mutually not exclusive shows that the event can simply what occur at the same time. So that's just know that one. So when we are doing example on it, when I'm solving this question on the board, you have a better understanding of it. Now you can pause the video and just go by it or just go through it. Now let's solve question one. This question one fall under what experimental what probability. They say what is the probability of getting what three by rolling a standard what six-sided die. Now we all know that a die is what six-sided. Question one is what six-sided. Now under the six side, you either have one, two, three, four, then five, and it was six. Now when you roll the die, you either have what one of this. Now they are not telling us what is the probability of what having what three. That simply is just what one. We can't have three more than two times there. So it's simply what one time. So that will now have one. Then what's now the total number of possible outcome, which is what six. So our answer is what simply one over six. So this one fall under what? Experimental. Now let's now move on to the second example, which is number 2. Then a coin was flipped twice. Get it? A coin was flipped twice. Then what is the probability of getting what? Two heads. Now there are two ways to solve this question. Now if a coin was flipped twice, that shows that you flip it the first time, I get now you either have what? A head or a tail. But the total possible outcome that time, the first one is what? 2. If you now flip it again second time, the other one is now what? 2. If you add everything together or you multiply everything together, is what? 4. That means the total number is what? 4. Now looking at this other one, you multiply it, is 4. Then if a coin was flipped twice, what is the probability of what? Getting two what? Heads. Now the first one, if you flip it first time, is what? 1 over 2. Then if you now flip it again, that's multiplication. Then because there is no O, or how will you know that is multiplication? Take note of this or. Now, if you anytime you see this or is very what? Important. So anytime you see this or, just know that it's not what? Multiplication. When we get there, you understand better. Now, here is what? Multiplication. Why? Because what? There is no or. Now, this one is what? Independent. If you wonder what? Independent multiplication part of probability is what? Independent. Now the first outcome is not what? Dependent on the second outcome. Then if you flip it again second time, you now have what? One head, and the possible outcome then is also what? 2. So if you multiply both, it's simply what? 1 over what? 4. So that's the answer. They can ask you to write it what? In what is it called? In percentage. So you can just if you want to convert to percentage, you just multiply by what? 100. You have your answer what? In percentage. Then let's now move to what? Example 3. Now, example 3, they say, what is the probability of rolling what? A die and getting what? An even number or a number greater than what? 3. Now, first of all, how you know that a probability question is either multiplication or a subtraction one? Take note of the or. Anytime you see or, just know that is what? Under what? Addition. Now, under the addition, that's why you now have the mutually exclusive and mutually not what? Exclusive. They say, what is the probability of what? Rolling a die and getting what? An even number or a number greater than what? 3. Now, first of all, let's write it. The probability of what? Having what? Now, you know, if a die, you roll it, either have what? A die has what? 6 possible what? Outcome. That's so. Let me write it. 3, 4, then 5, and what? 6. Now, the probability of what? Of what? Getting what? An even number. Now, what is the even? What are the even numbers there? We have this. You know, even numbers are numbers that can be divided by what? 2. And this. So the even numbers there, what? They are just what? 3. So 1, 2, 3. That's what the favorable outcome there is what? 3. Then total possible outcome is what? 6. That's the probability of what? Of even numbers. Let me just write this here. Of having what? Even numbers. Then what is now the probability of what? Having what? An odd number. Or having what? A number greater than what? 3. Sorry. A number greater than what? 3. The probability of having a number greater than what? 3. Greater than 3 is what? Which number are greater than 3? Is 4, 5, and what? 6. Which is what? 3. 3 over what? 6. Then after that one, there is now what? This is where the mutually not exclusive come in. Then the probability of not getting what? An even number, and also that is also greater than 3 is this. The probability of having what? An even number and a number greater than 3. Okay. Or a number greater than 3 is, let me just write the greater than 3 is what? Now, and a number that is even and is also greater than 3. Let's look at it. 4 and what? 6. They are even and they are also what? Greater than what? 3. So the answer here is just what? 2. 2 over what? 6. Now, this is where the mutually not exclusive. Now, the mutually not exclusive shows that the event can happen what? At the same time. You can see that we can have even number and a number greater than 3. That's why it's what? Mutually what? Not exclusive. Now, in solving this now we add everything together. The probability of even number and the probability of what? A number greater than 3. That's why the additional coming. Then you add it together. So that's 3 over what? 6 plus 3 over what? 6 minus. Why did I minus it? Why? Because this one is the event that happened what, at the same time. So we now have what, 2 over what, 6. So I can, let me just write the formula on the board. The first probability, probability 1 plus the probability 2 and for the probability of the two together, 2 and 3. So that's just the formula. You can just write it down. It's a better one. Then if you add everything together or you subtract, first of all, let's look for the LCM. You know, we have something like this. Look for the LCM for the, and the LCM is what, 6, because everything is the same. Now, after that one, we now add 3 plus what, 3 minus what, 2, which is, that's 6. 6 minus 2, that's what, 4 over what, 6. Here, 2 here, 3, 2 here, 2. So our answer is simply what, 2 over 3. 2 over 3. That's our answer. Now you can pause the video and go back it again. Now let's move on to question 4. So question 4 here says that what the probability of it not raining tomorrow is what, 20%. What is the probability that it will not rain? Now the probability that is to rain is what, 20%. Now imagine if something is certain that it will rain, you know, is 1%. That's 100%. That's what, 100. This one is also cost what, 100%. Now the probability of it now raining is just 20%. Now if you don't want to get the probability of it not raining, what are you going to do? You are going to minus the probability of this thing happening minus the one that it will, it will happen. You are going to get the probability of it not raining at all. That's 80%. Now what are you going to do? That's 1 minus 20. Now how are you going to do this one first? Convert this one to what is it called? You can decide to do it 4 ways. Convert it to either this one to percentage, that's 100%, or you convert this one to decimal. Let's convert this one to decimal. Now you divide it by 100. If you want to convert percentage to fraction, divide by 100. Here cancel. Here is 1. Here is what, 5. So we now have 1 over 5. So 1 over 5 divided by this, that's what, 0.2. We now have 1 minus 0.2, which is equal to what, 0.8, or 80%. Hope you got it. Now let's now move on to question 5. Now they said a bag contained what, 5 red marbles and 7 blue marbles. They say what is the probability of picking a red or a blue? Now what is it addition or multiplication? It's simply what, addition. Again, now why? Because there is or. This one, let's solve it. Now the probability of a bag contain what? What is that? What is the total number of possible outcome? Then add all the marbles inside the bag, which is 5 marbles plus 7 marbles. 5 red marbles plus 7 blue what, marbles, which is equal to what? Sorry, this marker is messing up. Which is what, 7 plus what, 5. Those are the total number of possible outcome, which is what, 12. 12 marbles. 12 marbles. Those are the total number of possible outcome. Then now as they say, what is the probability of what, picking what, a red or a blue what, marble? Now if you are going to pick, now since the bag contain how many marbles is what, how many marbles, 12. How many red marbles? We have what, 5. Now the probability of picking what, either a red or a blue marble. Now if the probability of picking what, a red marble is how many times? Is what, a red marble, that's what, 5. The possible chances is just what, 5. The favorable outcome is just what, 5 over what are the 12, what are the total possible outcome? It's just what, 12. Then this one will not be what, plus. Now for the other one, the probability of that picking what, a blue marble is now what, 7 over what, 12. Now if you now look at it very well, this one is not what, there is not like a mutually not exclusive. Why? Because the event can happen at what, at the same time. Now that's why our answer, this one fall under mutually exclusive under addition. Then if you collect like find the LCM, the LCM is actually what, 12. Then add everything that is up. That's 5 plus what, 7, which is what, 12 over what, 12, and everything is what, 1%. It shows that is what, 100% what, certain, or 100%. That's the answer. Now let's now move on to question 6. Now question 6 simply says what a box contains what 7 red balls. 7 what red balls. So the probability of the red balls is what 7. Probability of red balls is what 7. That's question 6. Is what 7. Then 6 blue balls. Then probability of blue balls is 6. Then I said, what is the probability of drawing what 2 blue balls without what replacement? Now looking at it very well, we have what the total number of possible outcomes is actually add everything together, which is what 13. That's the total number of possible outcome is what 13. 13. Then I said, what is the probability of drawing what 2 what balls without what replacement, and both are what red balls? Now looking at it, what is the probability of what of picking what a red ball is actually what 7. Now if the first one, then this question fall under what mutual, under multiplication. Now if you pick a red ball, I guess you know the first red ball, if you pick one, so before you pick it, we have what 7 over what 13. 7 over what 13. Then if you not replace it, then the other one will not be what sorry, I'm coming. 3 over what? Since you not replace it, 3 over what? 12. Now you can see that, oh sorry, there is multiplication. That's what 3 over what? 12. Why? Because when you picked one red ball, you didn't replace it. I guess you know. That's why this one is not 12, and this one is what? 6. Sorry, 6. Now since you not replace it, you remove one, then you not replace it, then the other outcome will now have 6 over what? 12. That's why this one is what? Dependent or mutual, because the first outcome, if you remove, if any year you see without replacement, just know that it fall under what? Mutual. And it's going to be multiplication when there is no or in the question. Then you should multiply. Then this one what is what 1, and why this one is what 2. Now since is what multiplication, then this is what 7, and this is what 20 what 6. That's 7 over what 26. Is it blue boss? Okay, red. So that's 7 over what 26. Over 26. That's your answer. I don't know if it's divisible, if it's divisible. So 7 over 26. So that's the answer. So with this, hope you found this thing helpful, and thank you for staying. And you can subscribe and share with your friends. God bless you. See you another time.